Dear students, today we will solve the problems based on the combination of resistors, and this will be on mixed combinations, special kind of combinations. So question 1 is, this is the B point and this is the A point. We have to find the net or equivalent resistance from A to B or between A to B. So this is 2 ohm, this is 2 ohm, this is 2 ohm, this is 2 ohm. So if you just try to see which one is in series and which one is in parallel, if we move like this, so again we cannot say this is series or parallel because there is some path connected over here. So we cannot say. Similarly, if we move this thing, then you cannot say it is with this series or with this or what. So this kind of problem is to be solved by a special method that we call it a Wheatstone bridge. Wheatstone bridge. This class 10th students also can do it. This is for 12th class, but this is very simple. If I say this is R1, this is R2, this is R3, this is R4, and this is R5. So what is Wheatstone bridge condition? So Wheatstone bridge condition is if R1 upon R2 is same as R3 by R4, then no current is to flow through this. This circuit can be drawn like this. See, this is A, this is R1, and let us call it B, P point, and this is Q point. So this is R1 connected to P point, and this R2 is connected to Q point. Just see, थोड़ा सा ध्यान देंगे समझ में आ जाएगा. From A we are connecting R1 to P, so we have connected this R1 from A to P. Similarly, this R2 is connected from A to Q. So this is R2 connected to this. And now from B, we have connected R3 to P. So this is R3. We have connected it from B to P. And so R4 is connected to from B to Q. So here it is R4. And then this R5 is connected between P and Q. So between P and Q, this R5 is there. So if the ratio of this R1 by R2, or this way, you can also have it R1 by R3 is same as R2 by R4. The same thing, just transfer it here and transfer it here, we will get the same. So if the ratio of these two ohms is same as the ratio of these two ohms, corresponding ratio, then no current will flow here. This I will be 0 here. So that means it is not contributing in any way, so you can just remove it. So once you remove it, then our circuit becomes, so here R1 upon R2 equals 2 by 2 and R3 upon R4 equals to 2 by 2. So here it is R1 by R2 is same as R3 by R4. Therefore, Wheatstone bridge condition is satisfied, and so we can, R5 can be neglected. So this is the only criteria or the trick, you can say, condition which due to which this can be removed. Now equivalent circuit becomes like this. This is R1, that is 2 ohm. This is R2, that is 2 ohm. And this is R3 equals to 2 ohm. And this is R4 equals to 2 ohm. So this is B and this is A. Now we see this R1 and R3 are in series, and R2 and R4 also in series, and then they are in parallel. So here you can have this R13 will becomes 2 plus 2, that is 4 ohm, and R24 becomes 2 plus 2, again 4 ohm. So here it is R13 is 4 ohm, and this is R24 is equals to 4 ohm, and this is B and this is A. Now we get 1 by R equals to 1 by 4 plus 1 by 4, that is 2 by 4, that is 1 by 2. So R equals to 2 ohm. Once again we can just see this is the combination which is mixed combination, and we have to see which resistors are in series and which one are in parallel, and accordingly we can solve. But the problem here is, if we consider this R1, so this R1 is connected with this R5 as well as R2, but in which combination? Neither it is in series nor parallel, because second line is not connected over here, some obstacle is here. Similarly with this, so we cannot solve it that way. So there is a special criteria which is called Wheatstone bridge. Class 10th student, just see and take care of it and take note of it. You can also do it very easily. So what is the Wheatstone bridge condition? That is, if the ratio, this Wheatstone bridge, that means this combination can be written or redraw according to this way. This is R1 is connected from A to P. Let us give this point as P and this point as Q. And easily you can draw the circuit diagram. Between A and P is R1, between A and Q is R2, and between B and P is R3, and between B and Q is R4, and again between P and Q this is only R5. So new circuit, the shape of the circuit has been arranged this way. Now here we have R1 upon R2 is same as R3 by R4, 2 by 2, and here is also 2 by 2. When this ratio is not same, then this cannot be neglected. This cannot be neglected. Then we will have a different way of solving it. There are certain methods. There are 2-3 methods by which we can solve it. I will discuss later on. So here no current is passing through this R5. So what is the use of connecting it? There is no use of connecting this circuit. जैसे कि आप घर में दिवाली में बहुत सारी लड़ी लगाई है आपने, लेकिन एक ऐसा भी लगा रखा है बल्ब आपने जिसमें जो चल ही नहीं रहा है, तो या फ्यूज है या उसमें करंट ही नहीं आ रहा है, खराब है, तो आप क्या करते हो? उस बल्ब को लटकाए रखते हो वहाँ लड़ियों के नीचे? नहीं, आप उसको क्या करते हो? हटा देते हो. तो सिमिलर थिंग इज हैपनिंग हियर. इस रेजिस्टेंस में देयर इज नो करंट, it is not using the current, so no use of connecting it here. We just remove it. So after removing this, the equivalent circuit becomes this, just see, and this arm is R2 and R4, and this is removed, so no connection. So now we see this R1 and R3 are in series, and R2 and R4 are also in series, and they are then in parallel. So R2 and R1 and R3 will become 2 plus 2, that is 4 ohm, and here it will become R2 and R4, this will be 2 plus 2, that is 4. So R13 is 4 ohm, and R24 is also 4 ohm. So here R13 is 4 ohm and this R24 is 4 ohm, they are in parallel. So net R will be equal to 1 by R. Now they are in parallel. 1 by R equals to 1 by 4 is 1 by 4, that is 2 by 4, that is 1 by 2. So R is equal to 2 ohm. So this is the correct answer. So this way you can do it. Now we can solve question number 2. We have to find the equivalent resistance between A and B. Find equivalent resistance between A and B. So here is A and here is the B. From A, this R2, R3 and R1 connected. From B, R4, R5, R6 are connected and they are connected over here. So again, if you move this way, so this and this are in series. But again, with this you cannot say, with this you cannot say. Similarly, if you take it this R1, so you cannot take with this as well as with this, neither series nor parallel. Similarly, from here B, you can have these two are in series, but again cannot tell. So let us call it X and Y. So now we can redraw the diagram. This is A. From A you are connected R1, and from here we are connecting two resistors R2 and R3. So here this point we are taking as Y and this point as X. From A to X we are connecting R1, and from A to Y we are connecting these two in series here. Now this is the B point. If I take it exactly here, B. So from B to X we are connecting R4. So then we will connect B, R4, and from between B and Y we are connecting these two, R5 and R3. So here R5 and R3, R5 and R6 are connected this way, and this R7 is connected between. So just identify the shape. Yes, you got it. So it is again like Wheatstone bridge, but it is, unless it satisfies the Wheatstone bridge condition, it cannot be said as Wheatstone bridge. Otherwise it will be a simple network. So here you see this is 2 and 2, so this is 4 ohm here, and R1 is also 4 ohm. Here it is R5 and R6, 3 and 3, they are 6 ohm, and this R4 is 6 ohm. So now the ratio of this and this is 4 by 4, and same is 6 by 6 over here. So they are equal. So Wheatstone bridge condition is applied. Now we can remove R7, can be neglected or removed. So we can remove it. एक बार फिर से देख लीजिए. These two are in series. So this is 4. This is already 4. These two are in series. So this is 6. 3 plus 3 is 6. And here it is 6, R4. Now the ratio, either this way you see the ratio this and this, or this by this. So it will be, if you say this by this, so it will be 4 by 6, and here also 4 by 6. So they are equal. Or this way. So you in both the ways it is satisfying the Wheatstone-Bridge condition. So we can remove this R7. After that, the equivalent circuit will become. So it is it is 4 ohm, and then it is 6 ohm. Here it is 4 ohm, and this is 6 ohm. So this is B and this is A. Now these two are in series. So if these two are in series, that means if I say it R23 and it is R56, it is R4, and this is R1, and this is R4. So here we can have R14 will be equal to 4 plus 6, that is 10 ohm, and R2356 becomes 4 plus 6, that is 10 ohm. And now we can have this as B, this is A, this is 10 ohm, and this is 10 ohm. So equivalent circuit resistance R1 by R will equal to 1 by 10 plus 1 by 10, that is 2 by 10, that is 1 by 5. So R becomes 5 ohm. Let us explain it again. These two are in series. We have just drawn it like this. This is from A to X. Okay, 4 ohm. Now this R4 is connected from B to X. B to X R4, that is 6 ohm. And these two are in series. So in series the resistance are added. It is 3 plus 3, that is 6 ohm. And they are connected over here. That is between B and Y. So B and Y, they are connected. Best way is just give the points. Like A and B are already there. You just take them X and Y and then plot here and there like this. You just say it is A. This is say, let us say this time I am saying X. कोई फर्क नहीं पड़ता उसको, आप इधर लें या उधर लें, कहीं ले लीजिए Y. ये कर दिया. अब आप A से कनेक्ट करके देखिए A से कितने कनेक्ट हो रहे हैं, R2 और R1. तो R1 कहाँ जा रहा है, X की तरफ, ये R1 बना दिया. R2 और R3 दोनों मिलके जा रहे हैं कहाँ पर, Y पे. तो ये R2 और R3 Y पे आ गए. अब B से शुरू करें. B और X के बीच कौन है, R4. B और X के बीच कौन है, R4. और B और Y के बीच कौन है, B और Y के बीच कौन है, R5 और R6. तो ये R5 और R6, और फिर बीच में 7 है. तो यही बन गया. तो ये समझ लीजिए क्या हो गया, ये पलट गया नीचे और कुछ नहीं हुआ. देखिए इसका अगर इमेज यूं पलट हो गए तो दिस इज द सेम डायग्राम. तो घबराने की जरूरत नहीं है. एनी वे यू ड्रॉ इट. आपके जो मन में आ रहा है उसको जहां पॉइंट आ रही है, जरूरी नहीं है मैंने एक्स ऊपर लिया है वाई ऊपर लिया तो आपने ऊपर ले कहीं भी ले सकते हैं आप. बट हौच पौच ना हो जाए, उल्टा सुल्टा नहीं हो इसलिए. तो अगेन दिस बाय दिस इज सेम एज दिस बाय दिस, और दिस बाय दिस इज सेम एज दिस बाय दिस. सो दिस इज R2 एंड R3. तो सब आ गया. तो अब यहां से क्या हुआ, वी कैन जस्ट सी द रेशियो 4 by 4, 6 by 6, or this by this, or this by this way. So that means this can be removed because this network is satisfying the Wheatstone-Bridge condition. So we can remove this R7. After removing R7, our circuit becomes this and this. This is 4 and these are 3 plus 3 is 6. And here it is 4 and again this is these two plus 6 ohm. Now it is 10 and 10, 4 plus 6 series. This is also 6, 10 and then they are in parallel. So R is equal to, so यहाँ से देखें ये 4 then 4, ये 3 plus 3 6, 3 plus 3 6, यहाँ 6 और यहाँ 6, तो पलट के भी आएगा तब भी 6 ऊपर से ऐसे ही बनेगा, वैसे करोगे तब भी वैसे बनेगा. तो दिस वे यू कैन जस्ट solve it.